Good morning, viewers. This is Kasturi Day. Today again, I've come to discuss the atomic structure according to ICSE syllabus class 8. So in my last video, I have stopped after discussing the discovery of nucleus. Okay, so I'll continue with that nucleus part only, start with the in the nucleus part. So just a second. Yes, this was the discovery of the nucleus. Okay, I told you in my last video that in 1911, Lord Rutherford, he was a New Zealand scientist. He did an experiment with protons, on protons and electrons. He wanted to find out the arrangement of the protons and electrons in an atom. Okay. So due to his experiment, there is a discovery of a small positively charged nucleus, which is in the center of the atom. Now, Rutherford's alpha particles, he bombarded a thin sheet of gold. He bombarded a thin sheet of gold, which is the thickness of that gold sheet was 0.00004 centimeter, and it bombarded with the alpha particles, with some alpha particles. He bombarded the thin sheet of gold with some alpha particles in an evacuated chamber, and he found that most of the alpha particles pass straight through the foil without any deflection in their path. And small fraction of these alpha particles are deflected from their original path by, say, small angles, and some of the particles, very few of them, they bounced back. Okay, according to his observations, this most of the space of the atom was empty, because that's why the alpha particles went straight. Okay, and some of them, they deflected due to the presence of positively charged mass in the atom. Heavy positively charged mass in the atom. There is some positively charged mass in the atom present, which due to which the deflection of the small alpha particles, small fraction of the alpha particles, occurred with small angles. Then the positively charged mass is very small, and that is very centrally located. Okay, only a few particles, that's why they bounced back. Okay, due to that's because there is repulsion of the same charge. Okay, so alpha particles are positively charged, and when they were coming to the coming near the positively charged mass which is present in the center of the atom, they bounced back. So that is that percentage of the alpha particles was very few in number. Now, based on his experiment, he suggested the Rutherford's atomic model. Now, I'll start with the discussion of this Rutherford atomic model. Now, according to his model, an atom consisted of mainly two parts: the centrally located nucleus and the outer circular orbits. Okay, now the centrally located nucleus is the densest part. Okay, and it is positively charged. Okay, the entire mass of the atom, that is concentrated inside the nucleus, and this nucleus, it is very small in size, which is compared to the size of the atom as a whole. If we consider the atom as a ball, a ping pong ball, the center, the nucleus size is like a what do you say, a size of a pea. Okay, not pea, you will say mutter, it will be the size of that much small mutter. Okay, so small it is. Okay, even smaller than that also you can say. Okay, so this is the comparison of the whole atom, size of the whole atom, and the small nucleus inside the center of the atom. Okay, now then the cricket ball are placed at the center of the stadium in the nucleus. See, so imagine how small the nucleus is. Whole stadium is the atom size. If you imagine that the whole stadium is the atom size and the cricket ball is so small in comparison to the the stadium, the cricket ball is the size of the nucleus. Okay. Now the electrons revolve in the circular orbits, that is in the shells, in the space which is provided around the nucleus. Okay. An atom is electrically neutral because the number of protons is equal to number of electrons, and the protons have the positive charge and electrons have the negative charge. That is, the number of positive charge is equal to the number of negative charge. That's why the atom is electrically neutral. Okay. Now, this model is similar to the solar system, that is the sun is at the center and the planets revolve around it. That is, electrons are revolving around the nucleus. Nucleus is the sun and the electrons are compared to the planets. The nucleus is at the center having the positive charge and electrons revolve around it. So Rutherford's atomic model, two things are there. That is, one is nucleus centrally located and the circular orbits which contains the electrons which revolve around the nucleus. Okay. So next, see, this is the picturization. See, this is the, you can see this is the nucleus and these all are the shells or orbits around which the electrons are moving, these electrons having negative charge, and the nucleus which contains the positively charged protons inside it. Okay. So this is the Rutherford's atomic model. Okay. And this is compared to the solar system. Sun is in the middle, in the center, and the planets which revolve around the sun. Like this, a nucleus is at the center and the electrons revolve around the nucleus like the planets. Next, we come to discovery of neutrons. So first we have come to the discovery of electrons, then protons, and now we come to the discovery of neutrons. In 1932, James Chadwick, he discovered another subatomic particle which is present in the nucleus having no charge. Okay. So the neutron, which he named as neutron. Okay. So because it have no charge, it has no charge. That's why it's named as neutron. Then mass, which is slightly more than the proton. Neutron has the mass which is slightly more than the proton. It is proton mass is 1.672 into 10 to the power minus 24, and neutron is 1.676 into 10 to the power minus 24, slightly higher than proton. Then actually it was considered that the mass of the atom is concentrated within the protons, whereas the electrons are practically no mass. Okay, therefore the atomic mass of an element is equal to atomic mass of the proton. Okay, previously it was considered that the mass of the atom is concentrated within the proton only, and electrons which are revolving around the this nucleus, they have practically no mass, and that's why the atomic mass of an element is mass of its proton considered. Okay. But experimentally, it was found that the mass of the protons are far less than the atomic mass. Okay, so atomic mass is much more than the mass of the protons. That means something is there which is added to the proton's mass to make the atomic mass. This deduced that some particles are present in the nucleus of an atom which have almost the same mass as protons but have neutral charge, because it will not change the the neutral nature of the atom, electrically neutral nature of the atom. So the subatomic particle which is present there in the nucleus will have no charge, because protons have positive charge, electrons have negative charge. So another charge will not if any of the subatomic particle is present, that if it has any of the charges, either positive or negative, it will make the atomic it will not make the atomic atom electrically neutral. They will have some positive or negative charge. It will have some positive or negative charge, but as it is electrically neutral, if as the atom is electrically neutral, the neutrons will have the subatomic particle which has been deduced by James Chadwick will not have any charge. Okay, and as the atomic mass is far more than the atomic mass of the the mass of the proton, therefore something is present, some subatomic particle is present which has a mass similar to that of proton. Okay, and that is added to that the mass of the proton to make the atomic mass, total atomic mass. Okay, so this is of the neutron. This subatomic particle, which was discovered in 1932 by James Chadwick, was named as neutron. Okay. Now, the properties of neutron. The mass of the neutron is slightly greater than the mass of the proton. I told you this 1.646 into 10 to the power, I'm sorry, it is 676 into 10 to the power minus 24 compared to 1.672 into 10 to the power minus 24. Okay. See, it will be 76. Okay. 1.676. Okay, not 646. Okay. So then it is electrically neutral, that is, it has no charge, and atoms of the same element may differ in the number of neutrons, which lead to the formation of isotopes. Okay, now one thing it is noted that same element atoms, but their mass is different due to the presence of neutrons. One atom having certain number of neutrons, and the other atom of the same element having a little more of neutrons or little less of the neutrons of the than the previous one. So that makes the isotopes of the same element. Okay. Now, the atom of hydrogen contains no neutrons, only protons and electrons are there. All other atoms contains all the three particles. Except hydrogen, all the other atoms have all the three subatomic particles. Okay, other than hydrogen. Okay, so hydrogen has no neutrons, only protons are there. Okay, but the isotopes of hydrogen, I'll discuss you in later on, that it has some neutrons presents. Next is properties of subatomic particles. See, the table of the table below summarizes the properties of these subatomic particles. Okay. Now, the particle, this electron, this has a symbol of small e to the power minus, and relative charges -1, and relative mass, mass of proton is equal to 1, and therefore electron is 1 by 1840. Actual mass is 9.11 into 10 to the power minus 28. Then proton has p plus, small p plus, this is the symbol. Relative charge is +1, and relative mass is 1, and actual mass is 672 into 10 to the power minus 24. And for neutron, it has a symbol small n to the power 0, and relative charge is 0, and relative mass is 1, and actual mass is 1.676 into 10 to the power minus 24. Next is structural stability of the atom. Okay. Now, it is known that there is a force of attraction between the particles in the opposite electric charges. We know that there is opposite charges which are present in the atom, and there's an attraction between them, that is between electrons and protons. It is expected that as electrons are lighter, charged and in constant motion, they would gradually lose energy. Okay, as they are lighter than protons and neutrons, so they will, and they are charged and they are always in motion. So they will constantly, while moving, they will start losing energy and come close to the nucleus and eventually fall into the nucleus. This can result in the structural collapse of the atom. Okay, see, if this is the electron which is moving around the nucleus, this is the nucleus. So it's moving around, losing and losing energy, and it's coming closer to the nucleus and it falls into it. But if this happens, then what will happen? There will be a structural collapse of the atom. But actually, this does not happen. Okay, this was not explained properly by Rutherford. Okay, so this was explained by a scientist who was named as Niels Bohr. Okay. Now, what is Niels Bohr's theory? Niels Bohr's theory is the electrons which revolve in fixed orbits or shells around the nucleus at a very high speed, with each orbit associated with a fixed amount of energy. According to him, he told that the electrons, they move around the nucleus in their fixed orbits or shells, okay, with very high speed and with a fixed amount of energy. They don't lose energy. Okay, the electrons in these orbits of shells do not neither gain or lose energy until an external force is applied on it. Okay, according to Rutherford, he told that the electrons, while moving, it will lose energy. But according to Niels Bohr, he told that they have their energy, they have fixed energy in their shells. Okay, and unless and otherwise an external force is applied, the electrons does not lose or gain energy. That is, their position is maintained. So the inward force exerted by the nucleus is counterbalanced by the outward force of the moving electrons. That is, the nucleus which is pulling the electrons towards it, and the electrons which is pulling itself out of the nucleus, these two forces are balanced, counterbalanced. This prevents the electrons from falling into the nucleus and making the structure of the atom stable. This counterbalance, this force prevents the nucleus from falling into the, this prevents the electrons from falling into the nucleus and making the structure of the atom stable. Okay. Now, next will be modern atomic model. I'll discuss in my next video. Please go through this. If you have any doubt, please do write in the comment box. You can also refer to my email ID kasturi74@gmail.com. Okay, and hope you are liking the videos. Press this like button, share with your friends so that they can also refer to my videos and get benefited from them. And do subscribe to get the notification of my next videos. Please, viewers, you are watching it. Please, I know you have watching it. Please do subscribe to get the notification of my next video. Okay, thank you for watching and have a good day.